Yeah, guys, good morning.
Good morning, ma'am.
Good morning, ma'am.
How are you all?
Fine, ma'am.
So, in the previous class, we have discussed already about back propagation. Okay. Guys, just I want to tell you one thing. In back propagation, you are having many mathematical equations. Please do by heart in your home. Okay. Without by hearting all these things, without seeing all these things, you don't know how to derivate or what are the different equations which are used here. Okay. So, can you see the screen?
Yes, ma'am.
Okay. So, in the previous class, I have discussing about I'm discussing about one problem which is related to sound. Okay. So, where we will be using back propagation. So, here, if you see the previous class, we have discussed what is linear equation, what is perceptron, all these things. Okay. So, while using perceptron, there will be only single perceptron, and from single perceptron, different input vectors has been assigned. They have they will be assigned. If what will happen, only the perceptron which is used over there for only here combinations, linear equations, linear values. So there we will be using only perceptron. Okay, so that is single layer perceptron. So to overcome that, if we are having non-linear equations or non-linear combination of values, non-linear combination of vectors. So at that place, we will be using back propagation, multi-layer perceptron. Okay. So here, single perceptrons can only express for linear decision surfaces. They cannot use for non-linear decision surfaces. Okay. So to overcome this, we will be using multi-layer networks. So with the help of backpropagation algorithm. Okay. So here I want to give you one example. So if, uh, after many spectral analysis of the speech, okay. So what a person will do, they wanted to know how the vowels sound. Okay. So between H and D. So I am taking it to letters H and D. Okay. So here there is one diagram. So here if you see, I want to uh, make the decision in between two alphabets, that is H and D, the words in between H and D. What are the words which are coming in between H and D, how they are spelling, and which word they are pronouncing. Okay, so likewise. So here, if you take the example H and D, we will be having different words like hard, hid, food, hard. So likewise. Okay. So if there are multiple letters, say head, third, heard. So likewise, the pronunciation is same. Okay. So here, this network is trying to understand how the vowels sound between H and D. So if you see on the left hand side, one neural network is there. Okay. So here, what is happening? Whatever the words which are there, that has been given as the input here. Okay. So what are the input we are having? We are giving H and D, the words in between H and D. Only these words has been given, and how they has been differentiated, how they are being classified. Okay, that has been done by using this particular network, that is multi-neural network. So here what is happening? This network is trying to understand how the vowels sound between H and D. If I say hard and HARD and HEARD, so here what will happen? The phonetics matters. Okay, so A is sounding in different way. Okay, so here in these two words, what is happening? A is sounding in different way. Okay, so in speech recognition, it matters a lot. Okay, it's very much important for them. Okay, so here spectral analysis of that particular speech is performed and two inputs are decided. So what is spectral analysis here? Spectral analysis is nothing but it means frequency of periodicity in the speech. Okay, so if you say head, it will take some frequency. If you take hard, if you say hard, what it will do? It will take some frequency. So likewise. Okay, so this is analyzed with some frequency of the sound. So it tells whether there are single letter or multiple letters. So from spectral analysis, what we are doing, we are giving two inputs. So if you see on the left hand side, network is there, one neural network is there. Here we are taking two inputs, that is F1 and F2. So these are given as the input through the input layer. Okay, and one single hidden layer, and it has 7 neurons. You can count, you can see in between one layer is there, that is called as hidden layer, and it of 7 neurons. Okay, so that will analyze in what way word have to be interpreted. So whether it has to be interpreted as head, had, could. So based upon the frequency, it will analyze the spectral analysis of the particular sound pronounces with the sound pronunciation. It will analyze which particular word it is. Okay, so this neural network is converting it into appropriate word. So if you see in the right hand side figure, in figure right hand side, it is decision surface. So what we are doing, whatever the data or whatever the data points which are there, that has been plotted in a graph. Okay, so data has been plotted after getting the output. Okay, so here if you see, there are different types of shapes: square shape, circle shape, plus shape. Okay, into shape. So likewise. So here square shape are recognized with head, word head, HEAD, and a triangle are recognized with heed, HEED, heed. So likewise. So there is lots of data points which has been plotted in the graph. That that is nothing but lots of data points can classify them easily by drawing it. When we plot this particular data in the graph after getting the output by using this neural network, we can easily identify. Okay. So what is the question here? Can I classify them easily by drawing the lines between them? That is nothing but what I have told you. When we are plotting the data on the graph, the data can be easily linearly separable? No. Why? Because the data is not linearly separable. It is non-linear separable. Okay. So here it is not possible. Linearly separable technique is not possible here. Okay. So after using the neural network, after getting the output, what we are doing, we are plotting the data in the graph. Okay. After plotting the data, what has happened? The data which has been plotted, that is not linearly separable. So it is non-linear separable model. So what I have to do? I have to draw some non-linear lines to separate the data points. So if you see in the x-axis, F1 is represented with hertz, Hertz, Hz. You can see that. On the x-axis, F1 is represented with hertz. So based upon the frequency of words pronounced, these data points are plotted on the decision surface. Here, F1 and F2 are two frequency measurements. That is H and D, what we are taking in the network. And here it is not possible the data to be linearly separable. Okay, so if you see, so I'm having some data. So after getting the data output, I've plotted the database. The data has been plotted here. Okay, so likewise, the data is plotted. So what has happened here? Whatever the data points which are there plotted on the decision surface, it can be linearly separated. So if you see here, I can draw a line in between these. Why? Because it has been plotted in a linear manner. Okay. So if I say now the data has been plotted like this. So here the data is like this. So what I am doing here, if I want to uh, use linear separable model, that is just only perceptron. So what it will happen? So this will be separated once. This is separated like this. This is separated like this. Okay. So this is separated like this. This is separated like this. So likewise, the data is separated. Okay, in a non-linear manner. Oh, okay. So the same graph is given here. So whatever the data which is there, that has been plotted in a non-separable manner. Okay. So here, linear separable problem is not possible. So what we do in this case, we will be using multi-layer neural networks. Okay. So how to use neural networks? So you will be having different types of choices. The choice one is either by using the units which are already learned with gradient descent. That is nothing but మన దగ్గర డేటా ఉంది, డేటా సిస్టమ్కి ఇచ్చినాము, సిస్టమ్ మొత్తం నేర్చేసుకుంది. సిస్టమ్ మొత్తం నేర్చేసుకుని మళ్ళీ ఏమైనా కొత్త డేటా ఇచ్చామనుకోండి, వెదర్ ద సిస్టమ్ విల్ గివ్ కరెక్ట్ డేటా ఆర్ నాట్. That is nothing but by using the already learned with gradient descent, whether the network will give correct output or not. So this is choice one. Okay. So example ఏంటి అని అంటే, you want to analyze some picture. ఏంటి అది పిక్చర్ ఎనిమల్ హ్యూమన్ దా. సో మనం ఏం చేస్తున్నాం అక్కడ, మోడల్ హ్యావ్ టు స్టడీ ఈచ్ అండ్ ఎవ్రీ పార్ట్ ఆఫ్ ద ఫోటో. Okay, some photo is there. So what should the model do? It has to study each and every part of that particular photo. So if you see here, you can see one picture. Okay, so just see that's all. So what is happening here? Model have to study each and everything about this particular picture here. Okay, so here I am giving some image, and the model has to study each and everything about the picture, because that animal may be held in the hands of the human here. If you see here, the whatever the picture which is there, the boy is holding the animal dog. Okay, held in the hands of the human animal. Okay, so likewise different pictures will be there. So how neural network will classify? So what it will do, each and every edge of the photo has to be taken as a feature here. Okay, so whatever the inputs which we give, so what we are doing, we are giving the inputs like this. Okay, so the image features, whatever the features which are there, so those are each and every image features, whatever those are there, that is given as the input. So that image is given in the form of inputs here. Okay, and that has to be learned by the neural network, and this is not possible with linear function. So single linear function today, this is not possible. So it has to learn non-linear functions. So this is choice one. Choice one lo single perceptron to be used చేసేదానికి it is not possible. Second ఏంటి, perceptron unit is not possible choice. Linear functions possible కాదు, single layer తోటి కూడా it is not possible. Okay, so what we will do here is, we will be using differentiable threshold unit. Differentiable threshold unit. Okay, so this is the topic, differentiable threshold unit. So what it is? So here in threshold unit, various variations in the output will be there. Okay, so oka image is daniki edo oka output vastadi, next time adi inko output vastadi. So likewise for a particular data we will be having different outputs. Okay, so here for this we will be using sigmoid function. Sigmoid unit is used. ఇక్కడ చూడండి ఫిగర్ లో sigmoid unit is used. What is sigmoid unit? Sigmoid unit is nothing but sigma. Okay, so that is represented in the form of sigma. So in the figure you can see one formula is there, that is sigma is O is equal to sigma of net. Okay, so sigma is nothing but sigmoid function. So what will happen in neural network? It will have, if you take different constants will be there. It will be starting with the one constant and different features. Figure lo chudandi, x1, x2, so on, xn undi. x0, w0 undi, w1, w2, so on, wn undi. So here x0 and w0 are the constant value. So which is used to begin. So why we are using constant here? So in neural network we use constant. It is intercept. ఎందుకు యూజ్ చేస్తున్నామంటే ఎగ్జాంపుల్ ఏంటి అంటే ఇఫ్ యూ టేక్ ఎక్కడో ఆప్షన్ జరుగుతుంది, ఏదో ఇంటికి ఆప్షన్ జరుగుతుంది. ఓకే, సో ఆప్షన్ అనేది ఎట్లా స్టార్ట్ అయింది? దట్ విల్ స్టార్ట్ విత్ సమ్ కాన్స్టెంట్ వాల్యూ. ఓకే, then what will happen? It will raises according to the people who are present over there. So in the same way, when we are generating any neural network, so that will be started with some constant. Simply start చేయడం కదా, కాన్స్టెంట్స్ తో స్టార్ట్ చేసి దాన్ని కొంచెం 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 పెంచుతాం. ఓకే, so every time each and every linear combination which is there, that will be started with some equation. X naught. మీ ఫిగర్ లో చూడొచ్చు, ఇక్కడ డస్ నాట్ ఎక్స్ నాట్ ఉంది. X naught is given as 1 here. So now these are given to the perceptron. Perceptron అంటే ఏంటిది? x1 ఒక perceptron, x2 ఒక perceptron, so on, xn are different types of perceptrons which has been used. అంటే input neurons. Okay, so now these input neurons are given to perform some summation. ఓకే, ఇన్పుట్ వాల్యూస్ దాంతో వెయిట్ వాల్యూస్ ఇస్తే మనకి అదంతా సమ్ అయ్యి మనకి ఏదో ఒక లీనియర్ కాంబినేషన్ ఈక్వేషన్ వస్తుంది. ఓకే, సో ఆఫ్టర్ సమ్మింగ్ దట్ ఈస్ లీనియర్ ఈక్వేషన్. సో నౌ దిస్ లీనియర్ ఈక్వేషన్ ఇస్ కన్వర్టెడ్ ఇంటూ సిగ్మాయిడ్ ఫంక్షన్. మీరు చూడండి ఫిగర్ లో ఇంకో సర్కిల్ ఉంది, దట్ ఈస్ స్పెసిఫైడ్ విత్ ఎస్. So likewise, different inputs has been given. This is sum by using summation, and here one symbol is used. This is called as sigmoid function. Now whatever the linear equation till now we have got here, adenti xi wi ఏదైతే వచ్చిందో sigma of xi wi ఏదైతే వచ్చిందో, so this equation will be converted into sigmoid function. Okay, so here the first layer is perceptron layer. So this is perceptron layer. It will help to build the linear equation. W naught x naught plus w1 x1 plus w2 x2. So likewise, so this is linear equation. Now this linear equation should be given as the input to the sigmoid function to get the output. Okay, so for this purpose we will be using sigmoid unit. Okay, akkada only single layer perceptron lo input value system danipoti weight system adi sum aitadi manaki output vastadi, కానీ అది ఎప్పుడు ఓన్లీ లీనియర్ కాంబినేషన్ కి మాత్రమే. సో ఇక్కడ మనకి ఏమవుతుంది, నాన్ లీనియర్ కాంబినేషన్ కూడా ఉంది. సో నాన్ లీనియర్ కాంబినేషన్ ఉన్నప్పుడు we will be using multi-layer perceptron. For that purpose we will be using sigmoid function. Okay, so here you can see sigmoid is nothing but sigma of net. So ఇక్కడ మనకి net value ఏముంది, that is equal to sigma of I is equal to 0 to n wi xi ఉంది. Okay, so this is sigmoid unit. Now we can precise it. Whatever the equation which is there, that can be precise. That is O is equal to sigma of w arrow dot x arrow. That is nothing but the vector of weights and the vector of input values, which are used by using dot product. So this is the formula which we will be using. So where this is converted again into sigma of y, that is equal to 1 by 1 plus e to the power of minus y. You can see the formula here. So here sigma is often called as sigmoid function, okay, and it is also called as logistic function, and here it outputs the range in between 0 and 1. Whatever the output which we will get, that will be ranging in between 0 and 1, okay. So this is about multi-layer perceptron. And in multi-layer perceptron, we will be using one more function that is called as tan h instead of sigmoid function. Sigmoid function, instead of using sigmoid function, we will be using tan h also. So don't worry about tan h. Every time we will be using sigmoid function only. Only sometimes the tan h is used. Okay, so leave that. So this is about multi-layer perceptrons. So here the algorithm which is used here is back propagation algorithm. So I'll show you one figure. So this is back propagation. Example. Okay. Now here we have lots of layers. Okay. And with each layer some error will be there. And one layer is associated with another layer. So if you see here in this figure, input is I1, I2, I3. ఇవి input గా ఇస్తున్నాము. J1, J2, J3 is one hidden layer. That is first layer, hidden layer 1. Hidden layer 2 ఏంటిది K1, K2, K3. ఇది hidden layer 2. Output layer లో ఏమొచ్చింది మనకి L1, L2, L3. Okay. So likewise you will be getting the output. So here one single input layer will be there. In between many hidden layers are there. Okay. So here what will happen in hidden layer also, in one particular hidden layer also will be getting, when we execute the network, we will be getting the error. Okay, that I'll show you with one example. Okay, and so we have to find the prediction error with each layer. So for that purpose, we will be using this formula. So E W vector equivalent to 1 by 2 summation of D belongs to capital D, summation of K belongs to outputs, TKD minus OKD whole square. So what it is? The error measure with respect to weight vectors. E brackets లో W arrow అంటే ఏంటి అని అంటే error measure. We are measuring the error. Error measure with respect to weight. Okay. So what we are doing? We are having different types of input values. Okay. In between this, hidden layers are there. Each and every neuron is connected to the hidden layer with neurons. Okay. So what we are doing? These are input layers X1, X2, X3, X4. input layers. X1 W11 dash, W12 dash. So likewise, weights ఉంటాయి. ఇది hidden layer 1. Hidden layer 1 లో weights ఇక్కడ end అయిందో. So that is W, W1, W2, W3. So ఇది W51 dash. So likewise, okay. It is W, W1, W8. The W8 W8, okay, the W9. So error measure with respect to weights. So ikkada రావచ్చు మనకి ఎర్రర్, సింగిల్ న్యూరాన్ లో రావచ్చు ఎర్రర్, ఇక్కడ హిడెన్ లేయర్ లో సింగిల్ న్యూరాన్ లో రావచ్చు ఎర్రర్. So what is happening? The formula which we are using, that will measure with respect to different weights which are used in the network. Okay, so that is E of W vector. That is equivalent to half of for every training example. Training example అంటే ఏంటిది? డేటా సెట్ తీసుకున్నారు. డేటా సెట్ లో 10,000 రోస్ ఉన్నాయి. 10,000 రోస్ ఉంటే ఇండివిజువల్ రో, that is called as training example. Every training example which is there in the data set. Okay, so every training example in the data set and every layer of K that belongs to output layer. Okay, and that will calculate the error of TKD minus OKD whole square. అంటే ఏంటి అని అంటే మనం ఏం చేస్తాం ఇక్కడ సమ్ స్క్వేర్డ్ ఎర్రర్ యూజ్ చేస్తాం. దట్ ఈస్ నథింగ్ బట్ summing up all the square of different errors which are there in the network. So ఇప్పుడు ఏం చెప్పాను నేను, ఇక్కడ ఎర్రర్ రావచ్చు, ఇక్కడ ఎర్రర్ రావచ్చు, అది హిడెన్ వన్ లేయర్ లో. ఈ న్యూరాన్ దగ్గర ఎర్రర్ రావచ్చు, ఈ న్యూరాన్ దగ్గర ఎర్రర్ రావచ్చు. సో దీస్ ఆర్ ఆల్ సమ్డ్, some square of all these errors for each and every training example which is there in the data set. That is nothing but E of W vector equivalent to half of sigma of D belongs to the summation of K belongs to outputs TKD minus OKD whole square. So this is the formula which we will be using to minimize the error here. Okay. So this is the algorithm. What is that algorithm? Back propagation. Training examples ante మీ data set lo training examples ante ఎన్ని rows ఉన్నాయి. So that is training examples. Comma. That symbol is called as learning rate. Okay. So learning rate ante ఏంటి అని అంటే if you want to travel from one place to another place. Okay. Or I'm having some hill. Okay. So I want to climb here to here. So I want to travel from here to here. So what I will do? Slowly I'll climb step by step, step by step. Okay. So what I'm doing here is I'm using some learning rate to climb up to tree, top of the tree here. Okay. So whatever the rate which I'm using in between this, that is called as learning rate. Okay. So మనం neural network hidden layers లో ఎన్ని సార్లు, how many times I have to do the iteration, and what is the value and how I have to use that. So that is all nothing but learning rate. Learning rate ante optimum value should be given. So some optimum value should be given. That is nothing but learning rate. Okay, so that is training examples, comma, learning rate, comma, n in. N in ante input number of input nodes, n out ante number of output nodes, n hidden ante number of hidden layers in the network. Okay, so here each training example is pair of form x vector comma t vector. X vector ante input values, t ante ఏంటిది target value. ఆ particular instance కి output ఏంటి. Okay, so that is x vector comma t vector. Arrow it is specifying vector. So here where x vector is the vector of network input values, t vector is the vector of target network values, output values. Okay, and here the symbol which is used is learning rate. Here he has taken the learning rate value as 0.05. N in ante number of network inputs, hidden n hidden ante number of units in the hidden layer, n out ante number of the outputs in the output layer. Okay, so now create a feed forward network with n in inputs, n hidden inputs, and n out outputs. So this is the algorithm which we will be using. Just see once whatever the formulas which I have discussed, that only given here. So this is back propagation algorithm. Okay, so I'll give you one example. With that you can know. The artificial neural network with hidden network. Okay. So what we are doing here, x1, x2, these two are two input values. With that we are giving w1, w3 are x1 input values, weight values, w2, w4 are the weight values of x2. Okay, and for x1 with respect to w1 and w3 you will be getting some output here with linear combination with in and out value. Okay, so these are called as hidden layer values h1 and h2. Okay, okay, so x1 x2 with respect to w1 w2 w3 weights ఇచ్చేసాము. మనకి ఏమవుతుంది హిడెన్ లేయర్ లో అది క్యాలిక్యులేట్ చేసుకొని ఇన్ వాల్యూ x1 w1 x1 w2 x2 w2 x2 w4 ఇట్లా కాంబినేషన్ లీనియర్ కాంబినేషన్ తీసుకొని మనకు ఒక వాల్యూ ఇస్తుంది. That is in that is in, and with respect to that we will get some output. Okay, so here also you may have some error, that is in hidden layer 1. So you will have you are having one more, that is in H2 also you may have some error. Okay, so these two are combined and you will be getting one more output, that is in and out with respect to W5 and W6 weights with some bias. Okay, so here you will be getting the output. So now this is your training data. Training data లో x1 value 0.1, x2 value 0.3. మనకి ఏం రావాలి 0.03 అనేది మన observed data. Okay, so this data is given to the network. Now what we have done, we have given some initial weights. వెయిట్స్ అనేది మనం ఓన్గా ఇస్తాం మనం. ఓకే, సో వెయిట్స్ ఎట్లా ఇచ్చాము, w1 is equal to 0.5, w2 is equal to 0.1, w3 is equal to 0.62. సో లైక్ వైజ్ వీ హ్యావ్ గివెన్ డిఫరెంట్ వెయిట్స్. దానికి తగ్గట్టుగా మనం we are giving the bias also. Bias 1 కి 0.4, bias 2 కి -0.1, bias 3 కి 1.8. So this also we are assigning. So we will be assigning some values to weights and bias also. Now, so that has been given to the network. Now what has happened? We have assigned the initial weights. The model has been trained and it has been predicted something. So it has predicted some value. So that is not correct. So now what will happen? It will back propagate. Okay. So what it will do? It will feed the weights again. So that is nothing but the weights has been updated. Okay. So it will update the weights. So now you see here, while giving the input values H1 in, you see in the figure, in H1 in, the linear combination is x1 into w1 plus x2 into w2 plus bias function, which is used for the input values with respect to the weight values. One bias function is used. So with that, what we have got, H1 in we have got as 0.48. అంటే ఇక్కడ ఇది 0.48 వచ్చింది మనకి. Okay, so for that, what we have did, we have used the sigmoid function. Linear combination అయిపోయింది, ఇప్పుడు మనం sigmoid function యూజ్ చేస్తున్నాము. Sigmoid function the formula, this is the sigmoid function, what I have told you, 1 by 1 plus e to power of minus net అనేది ఇంతకుముందు చూసిన ఫార్ములా. So the same which is used here. Okay, so this is the value where we will be getting over here. Out value ఇక్కడ వస్తుంది. In value ఏంటి, లీనియర్ కాంబినేషన్ తోటి వచ్చేసింది. లీనియర్ కాంబినేషన్ కి మనం ఏం చేయాలి, సిగ్మాయిడ్ ఫంక్షన్ యూజ్ చేయాలి. సిగ్మాయిడ్ ఫంక్షన్ యూజ్ చేస్తే this is the formula which we will be using. So we will be substituting the values and we will get the value as 0.618. Okay. Now, in the same way, for H we have this. For H2 also, we will be substituting the values, these values. After substituting the values, H2 value will be 0.506. Okay. So now what has happened? Output layer lo out ఏమని వచ్చింది, అవి రెండింటిని హిడెన్ లేయర్ 1, హిడెన్ లేయర్ 2 రెండింటిని కలిపి మన అవుట్పుట్ లేయర్ ని వాల్యూ వస్తుంది. ఓకే, సో ఇక్కడ అవుట్ ఇన్ అంటే ఏంటి అంటే ఈ వాల్యూ, ఆ అవుట్ ఇన్ వాల్యూ ఏమని వస్తుంది, అది లీనియర్ కాంబినేషన్. అగైన్ at that place also we will be using linear combination. After that will be converted by using sigmoid function. Then we will get the output value here. Okay, so here the values which are used in out in with respect to those values we are getting 1.858. Okay, after using the sigmoid function we are getting the value as 0.865. This is our predicted output. After implementing all the values, we are getting 0.865. Okay, so if you see here, after implementing the neural network with respect to the back propagation, మనకి ఏం రావాలి, desired output 0.03 రావాలి, కానీ మనకి ఏమని వచ్చింది ఇక్కడ 0.865 వచ్చింది. Okay, so there is some error. So what we have to do, we have to reduce the error here. So what we are using here, we are using gradient descent rule, that is delta rule. So that is equal to half of desired minus out. మన desired ఎంత ఉంది 0.03, మనకి predicted ఎంత వచ్చింది 0.865. So what is the error here, 0.349. So what we have to do here, we have to derivate those values. So after partial derivation, what will happen? So in this way, you'll be using the formula E minus W5 అంటే ఏంటి అని అంటే weights అవుట్పుట్ లేయర్ కున్న వెయిట్ వాల్యూ దాన్ని డెరివేట్ చేయాలి, W6 వాల్యూని డెరివేట్ చేయాలి, నెక్స్ట్ W1 W3 ఇవన్నీ డెరివేట్ చేయాలి. All weights has been derivated, partially derivated, okay, by using the formula. So now all the errors of the weights after partial derivation, these are the errors where we are getting. And each and every neuron daggara, output neuron daggara, hidden layer neuron daggara, we are getting the errors. Okay. So now what we have to do, as we are getting the errors, we have to update the weights. Okay. So initial ichna weights anni correct kaadu. So what we have to do here, we have to change the weights again. The weights anni mandi changes. Again we have to repeat this process from here onwards. And it will start here. Only what will happen? It will calculate H1 value, H2 value. Okay. Output layer lo in-out value calculate cheskoni. It will find the error. Again, if we are getting the error, what it will do? It will find the gradient descent data error value ఎంత వచ్చింది, దానికి irrespective of that we have to calculate the derivatives of each and every weight by using the formula. Okay, if again we are getting the errors over all the neurons in the hidden layer also, in the output layer also, we are definition also, 2 to 4. Yeah, you can leave, Amma.